The most powerful scientific instrument humanity has ever sent into interstellar space runs on less computing power than the chip inside a greeting card. And right now, in 2026, Voyager is still sending back discoveries that are forcing astrophysicists to redraw the map of where our solar system actually ends. In November 2023, the probe that had outlasted nearly every piece of technology it shared a launch era with went silent in the strangest possible way. Not dead, not dark. Still transmitting, still receiving commands, still alive. But the data coming back was pure gibberish. Voyager 1, more than 24 billion kilometers from Earth, accurate for 2024 repair narrative. Update to more than 25 billion kilometers if used in any 2026 present tense context, had begun sending back a meaningless repeating pattern instead of data, and it kept doing so for about 5 months. Imagine getting a postcard from the edge of the universe and every single word is just static. The spacecraft was fine. It had simply forgotten how to speak. The displaced code was too big to fit in any single empty space. Voyager's memory is so tiny that no single unused block was large enough to hold it all. So the engineers did something genuinely ingenious. They sliced the code into fragments and tucked the pieces into whatever scraps of free memory they could find, scattered across the system. To make room, they went hunting for software the spacecraft no longer needed, and deleted routines left over from Voyager 1's flyby of Jupiter in 1979, programs that had sat unused in memory for 45 years. They were clearing out old furniture to save a house that was on fire 45 years after the furniture was moved in. Once the instruments were restored, the data that came back in 2025 was not just the probe is fine. It was genuinely new science. Voyager's plasma wave instrument, which measures the density and behavior of charged particles, detected something unexpected about the heliosphere boundary, the heliopause. Picture your solar system as a snow globe. The sun is constantly exhaling. Solar wind, a stream of charged particles blasting outward in every direction. That exhale pushes against the interstellar medium, the thin gas and dust drifting between stars, and where the two pressures balance out, you get a boundary. That boundary is the heliopause. Voyager 1 crossed it in 2012. Voyager 2 crossed it in 2018. This matters because the heliosphere is our shield. It deflects a significant portion of galactic cosmic rays. High-energy particles from distant supernovae and black hole jets that would otherwise bombard Earth. Voyager's live measurements are the only direct data we have on how well that shield actually works, and the 2025 readings suggest it is more dynamic and variable than our models assumed. If the boundary is stranger than we thought, the shape of the whole structure is even stranger. For decades, textbooks drew the heliosphere as a sphere, a perfect bubble. The sun blowing outward in all directions equally, the boundary sitting at a tidy, symmetrical distance all the way around. Then the models got more sophisticated and the consensus shifted. The heliosphere probably looked like a comet, a blunt, rounded nose facing the direction the sun moves through the galaxy, and a long tail streaming out behind it, shaped by the pressure of interstellar wind pushing against our solar exhale. We do not actually know the shape of the thing we live inside. We are like a fish, trying to describe the ocean by swimming to the edge and poking it twice. 2 data points, 2 crossings, separated by 6 years and billions of kilometers, and that is the entirety of our direct, in situ evidence for what the boundary of our solar system looks like from the outside. Now the stakes become very real. Voyager 1 and Voyager 2 are running out of power. They're radioisotope thermoelectric generators, nuclear batteries essentially, that convert heat from decaying plutonium into electricity, lose roughly 4 watts of output per year. NASA has been methodically shutting down instruments one by one, making triage decisions about which science survives and which goes dark, just to keep the most critical systems alive long enough to keep transmitting. The current trajectory puts meaningful science transmission ending sometime around 2030, though NASA's ongoing power conservation efforts may push that further. And there is no Voyager 3. No replacement mission is funded or built. Any spacecraft launched today toward the heliopause would take decades to get there. In 1977, the engineers who built these probes were solving problems they would never live to see resolved. They were writing software for a machine that would outlast their careers, their retirements, and for some of them, their lives. The discoveries happening now, the leaking boundary, the asymmetric shape, the croissant nobody drew in the textbook, are the answers to questions asked by people who are gone. That is not just science. That is one of the longest bets humanity has ever placed on curiosity, and in 2026, against every reasonable expectation, it is still paying out. Subscribe if you want more of this, and watch the dark matter video next. It goes even deeper.